Great day, learners! Welcome to another fun and interesting math learning experience. What are you waiting for? Grab your pen and paper, your self-learning modules, or your compendium of notes, and together, let's rock math. This week, we will learn about zero and negative integral exponents. How does that sound to you? Now, if you are ready, let's unlock another math knowledge. But before we proceed to our discussion, let's have a quick review of what we have learned about the different laws of positive integral exponents. First, we have here the product rule, wherein when we multiply terms with the same basis, we just add their exponents. Second, we have the quotient rule, wherein when we divide terms with the same basis, we just subtract their exponents. Third, we have the power of a power rule, wherein we just multiply the inner and the outer exponents. Third, we have the power of a product rule, wherein we just distribute our exponent. And last, we have the power of a quotient rule, wherein we distribute also our exponent to both the numerator and the denominator. Now, let's extend the definitions of exponents by including all integers and learn some rules for working with integral exponents, specifically those with zero and negative integral exponents. Let's start off with zero exponents. For zero exponents, it says that if a is any non-zero real number, then a raised to 0 is equal to 1, meaning a can be any number excluding 0, and if it is raised to 0, it is equal to 1. Let's have our first example, 6 raised to 0. Since 6 is a non-zero number and it is raised to 0, then definitely it is equal to 1. Next, we have negative 3 raised to 0. Again, we take the definition of zero exponents, but we take the negative as well. So negative 3 raised to 0 is same as negative quantity 3 raised to 0, which is equal to negative 1. It is negative 1 and not positive 1, since negative 3 is not entirely raised to 0. Next, we have negative 5 raised to 0. For this example, negative 5 is entirely raised to 0, so the answer will be equal to 1. Next, we have 4x raised to 0. For this example, the zero exponent only applies to x. So 4 will remain, and x raised to 0 will be equal to 1. So we have 4 times 1, which is equal to 4. Next, we have 4x squared y cubed z raised to 0. At the first glance, this example seems to be complicated, as it involves a lot of variables. But if we observe it closely, it is entirely raised to 0, so the answer will just be 1. That's it for zero exponents. This time, let's learn about negative exponents. For negative exponents, if a is raised to negative n, it is equal to 1 over a raised to n, where a is not equal to 0 and n is a counting number. From this general rule, we can generate other important rules for negative exponents. First, we have where a raised to negative 1, which is equal to 1 over a. Next, we have 1 over a raised to negative n is equal to a raised to n. So we just take the reciprocal and take the positive exponent. The third rule is the quantity a over b raised to negative n is equal to the quantity b over a raised to n. So same as with rule number 2, we just take the reciprocal of a over b, which is b over a, and we take the positive exponent, which is n. Now let's have examples applying the definition of negative exponents. First, we have here 3 raised to negative 5. For this example, let's take the definition of negative exponents. So this will become 1 over 3 raised to 5. And if we further simplify the denominator, this will become 1 over 243. Next, we have 2x raised to negative 7. For this example, the exponent negative 7 only applies to x. So this becomes 2 times 1 over x raised to 7. We simplify, this becomes 2 over x raised to 7. Our third example is quantity 4w raised to negative 2. In this example, 4w is enclosed and it is entirely raised to negative 2. We take the definition of negative exponents. This becomes 1 over quantity 4w squared. Since 4w is still enclosed, we still need to distribute the exponent. This becomes 4 squared w squared, which is equal to 1 over 16 squared. Next, we have 1 over y raised to negative 6. For this example, we take the definition of negative exponents. This becomes 1 over 1 over y raised to 6. We simplify this by proceeding to multiplication. This becomes 1 times the reciprocal of 1 over y raised to 6, which is y raised to 6 over 1. And if we further simplify, this becomes y raised to 6. But if you can remember the second rule from the 3 rules that we have generated earlier, which is 1 over a raised to negative n equal to a raised to n, we can apply that on this example. So we can write this as y raised to 6 right away. Next, we have the quantity 7 over 3 raised to negative 2. Remember the third rule of negative exponents, which is the quantity a over b raised to negative n, which is equal to the quantity b over a raised to positive n. We can apply that rule on this example. We take the reciprocal of 7 over 3, which is 3 over 7, and we take the positive exponent, and in this case it will be 2. And then we will apply the power of a quotient rule and distribute 2 to both the numerator and denominator. So this becomes 3 squared over 7 squared, or if we further simplify, this becomes 9 over 49. Our next example is x raised to negative 3 raised to 2. Let's apply first the power of a power rule, wherein we will multiply the negative 3 and positive 2. So it will result to x raised to negative 6. Then we take the definition of negative exponents. So this becomes 1 over x raised to 6. We have here our next example, 12a cubed b raised to 4 over 4a raised to 5 b raised to 4. For this one, the first thing that we should do is to separate the example by like terms. So this becomes 12 over 4 times a cubed over a raised to 5 times b raised to 4 over b raised to 4. And then we apply the quotient rule. 12 over 4 will become positive 3. A cubed over a raised to 5 will become a raised to 3 minus 5 by applying the quotient rule. B raised to 4 over b raised to 4 will become b raised to 4 minus 4 by applying the quotient rule as well. We simplify, this becomes 3 times a raised to negative 2 times b raised to 0. And then, we take the definition of negative exponents for a raised to negative 2. So this becomes 1 over a raised to 2. And then b raised to 0, we take the definition of 0 exponents. This becomes positive 1. And then we take the product of these three. The answer will be 3 over a raised to 2, or 3 over a squared. We have here number 8, quantity negative 4x cubed y raised to negative 2 raised to negative 3. The example is enclosed and entirely raised to negative 3. The first thing that we should do is to apply power of a product rule. This becomes negative 4 raised to negative 3, x cubed raised to negative 3, y raised to negative 2 raised to negative 3. And then we apply power of a power rule. Negative 4 raised to negative 3 will still become negative 4 raised to negative 3. X cubed raised to negative 3 will become x raised to negative 9. And y raised to negative 2 raised to negative 3 will become y raised to 6. We take the definition of negative exponents. This becomes 1 over negative 4 cubed times 1 over x raised to 9 times y raised to 6. We take the product of these three. This becomes y raised to 6 over negative 64 x raised to 9. We have here our last example, quantity x raised to 0, y squared over 5z cubed raised to negative 2. We apply the third rule of negative exponents. Let's take the reciprocal of x raised to 0, y squared over 5z cubed, which is 5z cubed over x raised to 0, y squared. And let's take the positive exponent, which is positive 2 in this case. And then we apply the power of a quotient rule. So this becomes 5 squared z cubed raised to 2 over x raised to 0 raised to 2 times y squared raised to 2. Let's simplify and apply power of a power rule. So this becomes 5 squared z raised to 6 over x raised to 0 times y raised to 4. And this becomes 25z raised to 6 over y raised to 4. To wrap up this session, let's have a quick recap. This session we have learned about zero exponent, wherein if a is any non-zero real number, then a raised to 0 is equal to 1. We also learned about negative exponents, wherein a raised to negative n is equal to 1 over a raised to n, where a is not equal to 0, and n is a counting number. And also we have to remember the three important rules for negative exponents. We have a raised to negative 1, which is equal to 1 over a. And next we have 1 over a raised to negative n will be a raised to n. And the third rule will be the quantity a over b raised to negative n will be equal to the quantity b over a raised to n. I hope that the discussion today will help you answer the activities on your self-learning modules or the activities on your learning activity sheets. That's it for this session. I hope that you have learned a lot. I hope that you have made a progress and will continuously practice to do better and be better. If you are struggling, take time to learn it at a pace that you are comfortable with. You can do it. Anyway, let's meet each other next time for another math learning experience. Thank you for watching!